And then next up on our speakers list is the world-renowned Garth Gilmour, who's going to be talking about the wizardry of types in JavaScript. He's the head of learning at Instil. So on to you.
Cool. Thank you so much. Let me just share screen here. So just before I start into my talk, just a little comment on the previous one, just to second everything that was said about Ramda. Ramda is great, you know, and from a teaching point of view, it's absolutely brilliant. So I would really recommend it if you're doing like a little personal JavaScript project and you want to become like better at functional programming. Ramda will force you to get better at functional programming because, you know, as was said, it has features like curry and so on that are built in, you know, so it will force you to work in a more functional way. Okay, and also it'll expose you to more of what I like to call the functional toolkit, you know. So there are a certain set of core operators, yeah, that a functional programmer expects to find on their collections, you know. So we all know about for each, flat map, filter, you know, all that kind of thing, but there's dozens more, you know, and Ramda simply has more of these. Okay, so for a good example, unfold, you know, if you go to the Ramda.js website, you know, and look up unfold, you know, it'll take you a couple of minutes to work out what it actually does, but once you realize what it does, you'll see all kinds of opportunities for it, you know, and you'll get really angry, you know, whenever you're using a utility library that doesn't have an unfold function built in, you know. So yeah, Ramda is one of those things that it just makes you smarter, you know. You can feel yourself getting smarter as you use it, you know. In terms of performance and size and, you know, available documentation and all the rest of it, yeah, absolutely, you know, you're definitely probably better off with Lodash, yeah, but I would strongly recommend having a play with Ramda as well. It is just a really gorgeous wee library. I'm a huge fan. Yeah. Right, so let me just start into my talk here. So this is Type Wizardry for JavaScript Heretics, okay? So hello, my name is Garth and I'm here to annoy you, okay? Because I'm a big fan of compilers and I'm a big fan of strong typing, okay? And one of the things I'd like to do in the talk is just show you how you can add that to your JavaScript for fun and for your own benefit. You know, it'll make your code simpler, easier to maintain and so on. Okay, so just a little bit about myself. I was a full-time software developer for about 6 or 7 years, and then I started down the whole consultancy and training route. Initially thought I'd just try it for 6 months. That was about 20 years ago now. So it's you know, I've been doing this the training and consulting lark for about 21 years, which no longer sounds like a boast. It's starting to sound like a cry for help. Okay, so I've been teaching and consulting and doing that kind of thing for a couple of decades now. So this little presentation is essentially a mashup, yeah, of 3 ones that I've done previously, often in combination with other people. Okay, so huge thanks to Richard, Eamon, and Ross, and various other resources that I scavenged from over the internet. Okay, so you know, a goodly chunk of this is my own work, but large sections of it were inspired or just blatantly stolen, you know, from other people. Okay. So don't know much about you folks, except that you really like JavaScript, okay? So I'm going to assume that you're all like really dyed in the wool, you know, JavaScript developers, and you think that types are just completely evil, you know? And I'll start from that basis and trying to convince you that strong typing actually has its uses, okay? So Eric Major, way back in 2011, made lots of people very angry by saying JavaScript is the assembly language of the internet. You know, in other words, we should compile to JavaScript, but never really look at it, okay? And at the time, that was kind of true, because you had all these server-side frameworks that let you create components, you know, on the server side, maybe ASP.NET Web Controls or something like that, and they were just pumping out JavaScript and HTML that got rendered in the browser, and nobody ever looked at it, you know. But then those days went away, thank goodness, you know, and we all started to care about the JavaScript that we wrote, and we all started writing quality JavaScript code, you know. So this quote definitely became false, but it's kind of becoming more true again, because as you know, you've now got a shed load of programming languages that compile to JavaScript, okay? So you could be using TypeScript, you could be using ReasonML, you could be using PureScript, you could be using Elm. There's a bunch of different programming languages out there that now compile to JavaScript. And a lot of these are doing really interesting things with type systems, okay? So it's not like they're just trying to recreate Java or C#. That would be really boring, Instead, they're taking really novel approaches to how we manage types, okay? So the ones that we use in Instil are TypeScript and Kotlin, okay? So that those are our two go-to languages, So whenever we're working on a project, those would be the ones that we turn to first of all. So TypeScript, of course, for anything that we're doing in Angular or React, or if we're playing with the ADS CDK, or something like that, that would be TypeScript. And then for most other things, it would be Kotlin, So we're huge fans of Kotlin for Android and for server-side development in general. If you were doing any Spring Boot or microservices with Ktor or anything like that, we're big fans. And of course, both of these can produce JavaScript. Okay, so TypeScript, of course, transpiles directly to JavaScript. Yeah, with Kotlin, there's Kotlin JS. So Kotlin, like all modern programming languages, comes in 3 variants. Yeah, there's a version that compiles to bytecode for a virtual machine. In this case, the Java virtual machine. There's a version that compiles to JavaScript, Kotlin JS, and then there's a version that compiles to native code, assembly language, whatever you want to call it. So that's Kotlin native. Yeah, so if you're using Kotlin JS, well, of course, that's going to transpile to JavaScript. So I'd like to talk a little bit about these 2 languages, yeah, and how they can make your life easier, okay? Mostly TypeScript, because that's where most of the fun is regarding the typing, yeah? But then a quick word about Kotlin JS at the end, okay? Right, so let's get stuck into TypeScript, okay? You guys are, all dedicated JavaScript folks, so I'm sure I don't need to explain where TypeScript comes from. If it is new to you, then this little slide will explain here, okay? Oh, and by the way, I put into the general chat a link to a Git repo, and that contains projects for all the code I'm about to show you and a PDF of the slides, okay? So I want to show you an awful lot of code examples, so to get through them in a reasonable amount of time, I'll just fly through them in the slides, but they're all there in the Git repo in code. Okay. Right, so the first interesting thing about TypeScript is it's structurally typed, okay? So what on earth does that mean, okay? Well, let's define the same type 3 different ways. So in TypeScript, I can say type pair. So I'm going to declare a pair data type, and it will have a first, which is a string, and a second, which is a number, okay? So the type keyword is kind of the most general way that you can declare a data type in TypeScript. But then I could also use interface, okay? So TypeScript, in order to kind of, draw in the Java and the C# crowd and so on, it has the idea of interfaces, yeah. And then also, of course, we could declare a class, which we'll call dyad, So we're going to have a pair, we're going to have a tuple 2, and we're going to have a dyad. And each of those is going to have a first and a second. So nominally, these are different, okay? So in nominal typing, it's all about the name, okay? So these have different names, therefore they have different types, okay? However, in structural typing, yeah, they're all the same, okay? So these types are considered as being the same because they have the same structure, okay? So just to prove the point, let's create a function called test1 that takes a pair, a function called test2 that takes a tuple 2, and a function called test3 that takes a dyad, okay? And then we'll create an object literal with a first and a second, and we'll create a dyad with a first and a second, okay? So remember, test1 was declared as taking a pair, but I can pass in sample1 and sample2, and it'll work, okay? I can call test2 and I can pass in the object literal and the dyad, even though that's declared as taking a tuple 2. And I can call test3, and pass in my object literal and my dyad, even though that was declared as taking a dyad, okay? So it doesn't matter whether the function was declared as taking a pair, taking a tuple 2, or taking a dyad, it all just works, okay? Because these 3 types have the same structure, they're structurally identical. So if one of the things that's put you off trying TypeScript is you're thinking, ugh, you know, it just turns JavaScript into Java and who really wants that? That's not at all what it does. And that's not what it's about. Okay. So TypeScript brings a genuinely new and interesting way of thinking about types to the programming languages that we can use every day in industry. Okay. So structural typing gives you a lot more flexibility, a lot more freedom, you know, than you would have in a nominally typed system like you would get in Java or C# or something like that. Okay, so the first takeaway, you know, that I'd like you to take from this talk is that TypeScript gives you structural typing, you know, and that alone is worth playing with. But then there's a bunch of other goodies, you know, and I've listed them here, but let's see them in code. So you can declare aliases for types, okay? And this can make all the difference whenever you're maintaining other people's code, okay? So you see here, I've declared a type called myCallback, and I'm saying a myCallback is a function that takes a string, a number, a Boolean, and returns a map of strings against Booleans, you know? So when I declare something as a myCallback, yeah, I mean it's a link to a function, yeah, which takes a string, a number, and a Boolean, and returns a table of strings against Booleans. And then whenever I declare something of type myData, well, that means it's a tuple, okay? It's an array of 3 boxes, but the first box must be a string, the second box must be a number, and the third box must be a Boolean, okay? So you see here, I can declare a function called sample, and I can say, okay, this takes a myCallback, and it takes a myData. And what we can do is we can invoke the function by flattening the data. And TypeScript is smart enough to say, okay, func is a myCallback, therefore it must be called with a string, a number, and a Boolean, and myData is a tuple of string, number, and Boolean. So if you flatten that tuple, you get the arguments to the function. Happy days, it all works. Okay, so TypeScript will add that validation in for me. Okay, and then I can actually go out and you know, I can invoke the function and everything works and so on. Yeah. So type aliases give you a really nice way of taking your types under control, okay? And again, if you're only working with the code that you wrote yourself using frameworks that you know very well, happy days, you know? But a large part of my programming career was sifting through unfamiliar code bases that I didn't write using libraries and frameworks that I understood imperfectly, you know? So this kind of thing is really nice, that this really appeals to my experience in the industry, you know? Then other things, you see here, we've got union types. So I've declared a type for a point. It has an X and Y, obviously enough. But then I've declared this type called retval, okay? And I'm saying retval is either a string or a point or an element, okay? So what you can do in TypeScript is you can combine types together using or, okay? So we can say that whenever I say something is a retval, I mean it's a string or a point or an element, okay? And then I've got this function here, and it takes a number. And you see there, we're saying, okay, if the number is less than 50, return a string. Else, if the number is less than 100, return an element. Otherwise, just return output. Yeah. So, and that's the point of 20 and 40. So that's why the type of this is retval, you know, because it might return a point, or it might return a string, or it might return a node. Okay, so you see there we can combine the 3 different options, you know. So again, it's all about flexibility, you know. If you start converting some of your JavaScript to TypeScript, it's not going to be like putting on a straitjacket, you know. You're not going to be massively constrained in your types. You've got an awful lot of freedom. Okay. So I can go here and I can invoke my function. And if I pass in a number less than 50, I'll get a string. If I pass in a number less than 100, I'll get the node. Otherwise, I'll get the point. Okay. But you see here, let's say we invoke our function, and then I check to see if it's an element, okay? Well, if it is an element, yeah, then I can immediately use it as an element, okay? So unlike Java or C#, you know, if you say, okay, is something of type manager? Well, then in Java or C#, you would have to cast the reference to be of type manager, okay? So TypeScript is smarter than that. So TypeScript can look inside here and say, you've just checked that result is of type element. Therefore, you know, you should be able to call append child on it it, and so on. Okay, so it doesn't require casts when it can understand what's going on. Okay, and again, you can see the thought that's gone into this. You can see the flexibility and the freedom that you have. Okay. So as well as union types, you also have intersection types. So let's say we declare a type called an individual. Okay, so individuals can think and feel. And then let's say we define a type called machine. So machines can charge, yeah, and they can work. And then we'll define a type called Cylon. Okay, so a Cylon is everything an individual is and everything a machine is. Okay, so I can create new types by combining existing ones. Okay, so if I define Boomer, yeah, who's going to be a Cylon, yeah, well then she can charge, feel, think, and work. Okay, and TypeScript will ensure that I define those 4 methods. Okay. So as well as unioning types together, you can also have types that are the intersection of other types. Then you can have type literal values. What the hell is that? Okay. Well, consider Homer. Okay. So Homer is obviously a string. Okay. But if I say type Homer equals Homer, then I'm defining a new data type, which is only one member, the string literal Homer. Say that again. So if I say type Homer equals Homer, well, I'm declaring a new data type, yeah, and that new data type has only one permissible value, which is the string literal Homer. Okay, in the same way, I could say type my number equals 7. Okay, and then I'd have defined a new data type called my number, which could have one and only one possible value, 7. Okay, so the way you'd normally use this is with the bar. Okay, so you see here I've got a type called Simpsons, and I'm saying, okay, that's either Homer, yeah, or Marge, Bart, Lisa, or Maggie. And then we'll have a type called Flintstones, which is either Fred, Wilma, or Pebbles. Okay, and then we'll have evens and we'll have odds. So I've now declared new data types from literal values, and this can kind of be used in the same way as enums, except as we'll see, it can be a lot more powerful. So once I've done that, there's nothing to stop me combining them. Okay, so I'll have a function called demo1, and it's going to take some input, and that input will either be a member of the Simpsons, yeah, or an even number. And then we'll have demo2, and that will take some input, and that will either be a member of the Flintstones or an odd number. Okay, so if I go out and call it, I can call demo1 passing in, for example, Homer and 6, okay? Or I could call demo2 and pass in Wilma and 7, that would be fine. But I can't call demo1 and pass in Betty or 7, or demo2 and pass in Homer or 6, okay? So this is like a really, really powerful. And they've recently extended this. So in a recent version of TypeScript, they've extended this to give you template type literals. Okay, what on earth does that mean? Well, you see here, I've got a type called character, and I'm saying this data type is made up of a string, and it's a member of the rule type in, and then a member of the family type. Okay, so I'm saying if I declare a variable as being of type character, it must be a string, and that string must be made up of a member of the rule type in, and then a member of the family type. Okay, so you see here I've got demo, and that takes a string and a character. Okay, so I could call this by passing in mother in Simpsons, because mother is a rule and Simpsons is a family. Okay, or I could call it by passing in father in Griffins, because father is a rule and Griffins is a family. Okay, but I couldn't do it by saying dog in Jetsons. Okay, because Jetsons is a family, but dog isn't a rule. Okay, so you can see how we can build types by combining other types yet again. Okay, so this is obviously just a little bit of fun. When would you actually use this? Okay, so let's say you've got an object, and you know that the properties of that object are going to become events. Okay, so let's say you've got an object and the properties are foo bar z, and you know that all the properties of that object are going to end up as on start and on finish events. Okay, so you're going to have foo on start, foo on finish, bar on start, bar on finish, z on start, z on finish. Okay, well then it might be very useful to say, okay, there's this type called finish event, and it's made up of one instance of this other type followed by on finish, or you could have a type called on start event, and it's made up of one instance of this other type followed by on start, and so on. Okay. So you can use this to do strict type checking of the names of events and the names of functions and so on. Yeah. So pretty damn cool. Yeah. And then another one, another more recent feature. There's this thing called Const Assertions. What on earth is that? Okay. Well, here I've got some data for representing chess pieces, okay? So I'm going to have an array of tables, yeah? And you can see that each table defines a chess piece in terms of its name, its worth, and the actual shape of the piece, okay? So we have an array of tables of numbers and strings, until I put as const in the end, okay? So whenever I put this const assertion in the end, it converts the data, okay, to basically constant data. So instead of this being an array, this is now a tuple, okay? So it has a fixed size and it has a fixed format, okay? All of these tables are now immutable, you know, you cannot add anything to them, and all of the values are now the type literals, you know, that we were discussing before, okay? So now that this is all reference data, if you like, I can create data types from it, okay? So I'll create a data type called names, and basically this is going to be all the entries in the array with the name property, okay? So it's going to be the values of the name property of all the entries in the array, okay? So the names were, of course, pawn, knight, bishop, rook, queen, and king, okay? So this this data type called names, it can be one of those values, okay? It can be a pawn or a bishop or a knight or a queen or a king or a rook even, yeah? So I can say n1 of type names is a pawn, yeah? But I can't say n2 of type names is a sapper, okay? In the same way, worths will be the worths of all the pieces, yeah? So I can say 3, but I can't say 7. And shapes will be the shapes of all the pieces, you know? So I can say tar or tiara or crown, but I can't say coronet, okay? So I can define new data types based on the existing data that I've already defined, okay? So that's, you know, that's another really, really cool feature, okay? So, you know, what I'm trying to show you there is it's data typing, yeah, but not the data typing you may have been previously exposed to, you know. So if you went to college, you know, and you did your Java course and your C# course or whatever, your C++ course, and you absolutely hated those and you loved the power and freedom of JavaScript and you said, ugh, you know, I'm never going back to static typing again. Well, TypeScript approaches it in a completely new and interesting way, okay? So some of the stuff that it's giving you is what's called algebraic data types, okay? And this makes it really easy to sit down with the customer and define data, okay? So you see there, you know, that the way that we were using the types, you know, that's something that, you know, your business analyst or whatever can make perfect sense of, okay? That this doesn't look, you know, like complicated programming code, you know, that this looks like something you could actually read through and make sense of, okay? So that this gives us a really nice way to sit down with clients and actually define data, you know, right in front of them, okay? If you're interested in doing that, this is an absolutely superb book. I cannot recommend this enough, okay? So this shows you how to do domain-driven design with algebraic data types in F#, okay? But you know, the F# way of doing this is so similar to the TypeScript way of doing this that, you know, if you're a little bit familiar with the TypeScript stuff, you can dig into this and it'll all make perfect sense, okay? So cannot recommend this this book enough. Really, really good. Yeah. Right, so, you know, that's the basic stuff that TypeScript gives you. Let's move it up a notch, okay? The next thing that you have is something called mapped types, okay? So this lets you define one type in terms of another one, okay? So you see we've got a type here called Instil read-only of T, okay? So what on earth is that? Well, T is some type, okay? So here, whenever I say K in key of T, that's giving me the names of the properties. So whenever I say K in key of T, I'm iterating over the names of the properties, okay? So if T is a type with properties called foo, bar, and Z, well, whenever we say K in key of T, K will be foo, then bar, then Z, okay? And then if I say TK, you know, that gives me the type of the property, whatever it happens to be. So if I was to say K, yeah, in key of T, TK, yeah, well then that would give us basically an exact copy of the object, okay? So we would get foo bar and Z with the same data types, okay? But you see here, I'm saying read-only, okay? I'm adding the read-only keyword, okay? So an Instil read-only of T will be a data type which has exactly the same properties as T, you know, so that the same properties of the same types, but now everything will be read-only, you know, hence the name. Or I could take read-only off. I could say minus read-only, okay? So an Instil mutable of T will be a data type with exactly the same properties as T, with exactly the same data types, but now anything that was read-only will no longer be read-only. You know, we'll have left off the read-only, yeah. Or I could make everything partial, okay? So you see the question mark there in the penultimate one. So an Instil partial of T will be a data type with the same properties, the same types, you know, but now everything will be optional, okay? Or an Instil required minus question mark, you know? So it'll be a data type which is the same as T, the same properties, the same values and so on, but now we'll have taken the optionality off, okay? So we can create types based on existing types. Really, really nice, okay? So for example, let's say you've defined a data type with 5 properties and you've given all the properties proper types, you know, so something is a number, something is a Boolean, something is a date, you know, and so on. But then you're reading in data from the user interface and everything's going to be a string, okay? So you need a data type similar to the one that you've just created, but where everything's a string, okay? So you could manually declare it, you know, but then you'd have to keep the 2 data types in sync, you know, yuck, 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 okay? But what you can do instead, yeah, is you can declare a data type called, it's coming up right now, let me just find it. Here we are, yeah. So we can declare a type called stringify of T, okay? And this is going to be the same as T, but where everything is a string, okay? So let's say your existing type was foobar, you know, and it had those 5 properties that were well typed. Well, a stringify of foobar would have the same properties, yeah, but now they would all be of type string, okay? There's only one weakness with this, okay? That would apply to all the methods as well, okay? So let's say let's say foobar is a class, okay? So our class called foobar, let's say it has 5 fields and 3 methods, okay? Well, the problem is a stringify of foobar will have 8 strings, okay? Because all the methods will have been converted to strings as well, okay? So what we want to do is we only want to convert those properties which are not functions, yeah, into strings. And that's what we're doing here, okay? So whenever you do these mapped types, as they're called, you can use the ternary conditional operator, you know, the question mark conditional. So what I'm saying is, okay, loop over all the properties. And then if the type of a property extends function, okay? In other words, if this property of T is some kind of function, we'll then leave it alone, yeah? So if it extends function, we're going to replace it with itself, okay? In other words, we're not going to touch it, okay? Otherwise, make it a string. Okay, so the effect of this will be that a stringify fields T, yeah, will be a data type which is the same as T, you know, it will have all the same property names, you know, and all the same methods and so on, but the data type of all the properties, you know, will now be string. Okay, so you know, really, really interesting. Yeah. Cool. So it gives you examples of using all of this thing there, you know, all done. Okay. So you could go out and you could create all of these mapped types yourself, but it's an awful lot of work. Okay. So, you know, we were talking about utility libraries there, and we were focusing on utility libraries, obviously for JavaScript that give you the functional toolkit, you know, as I like to call it, you know, the extra functional operators that you don't yet have in standard JavaScript. Yeah. Well, same thing for TypeScript. Okay. So you can get, for example, you know, a library called the TypeScript toolbelt, and this gives you, you know, all of the mapped types that we've been talking about. Okay. So any mapped type that, you know, any seeing person would want, you know, you know, that this will be in libraries like this. Okay. So you don't have to write them manually, although that's very good for your own learning. Okay. So some of these map types are provided by the TypeScript language, you know, others are available in extension libraries. Okay, so you don't have to write them yourself. You can just go out and play with them. Okay. And then let's get a little bit weird. Okay, so the stuff I'm going to show you now, you don't have to use if you don't want to, but I just want to show you how far you can push the type system. Okay, so let's say we want to have a function called convert. Okay, and convert is going to take a value in either centimeters or inches. Okay, so we're going to have a data type called centimeters, and we're going to have a data type called inches. And the idea is that if we call convert and pass in a value in centimeters, well, the compiler knows we'll get back a value in inches. Okay, so on that we can call in yards. Yeah. Whereas if we call convert and we pass in a value in inches, yeah, well, then it's strongly typed to return a value in centimeters. You know, the compiler has complete metaphysical certitude, you know, that you're going to get back a value in meters. Okay. So how on earth would we do that? Okay, well, first of all, we declare a type called centimeters or inches, and that's centimeters or inches. Okay, so far, you know, but then we declare a type called centimeters or inches toggle. Okay, so what on earth is that? Okay, well, you see there we're saying, okay, if our type T extends centimeters, then we are inches. Otherwise, we are centimeters. Let me say that again, okay? If T extends centimeters, then this data type is inches. Otherwise, it's centimeters, okay? So in other words, a centimeters or inches toggle of centimeters is inches, okay? A centimeters or inches toggle of inches is centimeters, okay? So basically, it's going to be the reverse of whatever T is, okay? So I can go and implement my convert function, and the convert function is declared as returning a centimeters or inches toggle, okay? And I can hardwire it at compile time so that the compiler knows that if you pass in centimeters, it'll return inches. And if you pass in inches, you'll get back centimeters, okay? And the IntelliSense in your IDE will respect that, okay? So that's like an incredibly powerful feature, okay? But it is a little bit of a conjuring trick, okay? Because you could have done it with overloading, okay? So TypeScript gives you a slightly limited form of overloading, and that would be a much easier way of solving the problem, okay? So it's a nice conjuring trick, you know, but given that you could have done it with overloading, does this actually have any practical benefit? Yes, it does, okay? So here's a kind of extended version. Let's say we declare a type called HTML elements, yeah, and it's just a table here where we're saying, okay, associated with the string P is the data type HTML body element, label HTML label element, canvas HTML canvas element. I could have kept going, you know, but I just did 3 so we can read it on the slide. And then I've got this type called result element, okay? So we're going to have an input type T, which is some kind of string. And let's say T happens to be P, okay? Well, if T is P, well, then this result element will be an HTML body element, you know? Because you see what we're saying here is we're saying, okay, if T is in HTML elements, okay? So if T is a key in HTML elements, then use the corresponding value, okay? So if T is P, then result element T evaluates as an HTML body element, you know, and so on. So what I can do is I can write a little function called create element with ID, okay? So we're going to pass in the name of the HTML element that we want to create, an ID, and we'll get back a node, okay? But that node will be strongly typed, okay? So if I was to go here and say create element with ID P, well then at compile time, para will be set to a paragraph element. So on that, I will be able to set inner text, you know. If I say create element with ID label, yeah, well then what comes back will be an HTML label element. So on that, I will be able to set HTML4. And again, we'll get IntelliSense, you know, for all of this inside the IDE. If I say create element with ID canvas, yeah, well then what comes back will be an HTML canvas element, you know. So on that, I will be able to set height. Okay, so all of this will be strongly typed, but it'll be strongly typed without getting in the way, if you see what I mean. Okay, so there's some really nice magic going on there. You know, you can see how that could be really useful. Okay. And then so far, whenever we've been doing this type magic, we've always been assuming that T is something like string or customer or element or something like that, okay? But T might be a function, okay? So let's say the data type T represents a function type, you know, a function that takes a string and returns a Boolean, you know, or a function that takes two numbers and returns a date, you know, whatever. Well, then using the stuff that we've already seen, you can come up with a type called all params, okay? And this will return all the parameters of a particular function, okay? You can declare a type called first param, and this will evaluate to the first parameter of a function, yeah? You can define a type called other params, yeah? And this will evaluate to the other parameters of a function, okay? So, this can be really useful, okay? But here's a simple demo, yeah? So we've got a function called demo that takes a string, a number, and a Boolean, okay? That's the function called demo. So if I say all params type of demo, that will evaluate as a tuple of string, number, and Boolean. So if I declare a variable called var1 as being of type all params type of demo, you know, well, then I can set var1 to being a tuple of string, number, and Boolean, you know, because those are the types that demo takes. And then if I use first param, that'll just lift out the first parameter. If I say other parameters, that'll give me a tuple of the other parameters. Okay, very useful. Okay. So what could I use this for? Yeah, well, I could use it to implement partial invocation, okay? So this is very similar to currying, which was talked about in the first talk, okay? So let me just explain what it is first of all. So let's say we've got a function called find all matches, okay? Standard JavaScripty thing, okay? So we're going to pass in a regular expression. We're going to pass in a string that we want to search, you know, for matches for the regular expression. And then whenever we find a match, we want to store it in this array here, okay? So regex is our regular expression. Source is the string that we want to search. Output is the array into which we wish to insert matches, okay? So we could go ahead and implement it just like that, and that's fine. And you see here, I could call find all matches, okay? So let's say my regular expression is 3 uppercase letters, and I've got 2 strings that I want to search, okay? So all good, okay? Except I have to state the regular expression twice, okay? That's duplication, you know, and as developers, we do not like duplication, okay? So what we could do is we could partially invoke it, okay? So here I'm saying I wish to partially invoke find all matches, okay? So I'm going to get back a new version of the function, yeah, where the first parameter is hard-coded, okay? So if I partially invoke find all matches is a function that takes 3 inputs. I'm going to get back a function that takes 2 inputs, okay? Why? Because the first input has been hard-coded as the regular expression, okay? So now I'm going to call that function find 3 uppercase, you know, because I've hard-coded the regular expression. So suffice to say, you can go out and do that using the techniques that we've just seen, okay? I'm running a little bit short in time, so just to say I tried to do it one way. It didn't quite work. It got me 99% of the way there, and I got slightly annoyed, you know? So then I took some time off and came back and had another go at it, you know, and discovered a workable way to do it, okay? And that made me very happy, okay? So using TypeScript, even advanced functional techniques like partial invocation, you know, those can be implemented in a strongly typed way, okay? And then the final point, yeah, about mapped types, they can be recursive, okay? So you see here, I've got a little type called ink, okay? If you were to say like ink of 6, that would give you back 7. And then I've got a function, a type called deck, okay? So if you say deck of 5, that would give you 4, okay? And you say, you know, what possible use is this, okay? Well, I can write a recursive type called add, okay? So what we're doing here is we're saying, okay, you're going to call add and pass in 2 numbers, okay? And this is going to evaluate to add inc of A, dec of B, okay? So we're going to have here add, which is an inc of 5 and a dec of 3. But what we're saying here is, you see there, we're saying if B extends 0, yeah, well, then we do the return branch. You know, we return A, whatever that happens to be. So if type B has reached 0, then return type A. But if type B hasn't reached 0, then we do the again branch, okay? And you see in the again branch, we're doing an add of an inc of A and a dec of B. So if we say add 5, 3, that evaluates as an add of an inc of 5 and a dec of 3, which evaluates of an add of an inc of 6 and a dec of 2, yada, yada, yada. And eventually that comes back at 8, okay? So by performing recursion with mapped types, we can do arithmetic at compile time. Okay, so you know, now we're really off to the races. Okay, now we're practically Turing complete. Okay, so now we can do all our business logic at compile time. Maybe not, you know, but we could. Okay, so using this, you know, we can define code that works out what the head of a list is, or the remainder of a list is, or even reverses a list. Okay, so I can write code which at compile time, yeah, generates the reverse of any given list. I should really say tuple, you know. So here, if we have a sample list of Boolean, number, and string, a reverse of that would be a list of string, number, and Boolean. Okay, although you have to look at that for a while to work out what it's actually doing. Okay. So don't get too freaked out by those last ones. As I say, all the code is there in the Git repository, so feel free to dig into it and have a play, and feel free to email me with questions. You know, I'll put my email address into the chat in just a second. Okay. And by the way, I see there's a little question there. So where would you start with introducing types into an existing React project? Interestingly, there are any number of good tutorials on how to build a React app in TypeScript, okay? And that's what we actually do in the office, okay? So TypeScript is now our go-to, you know, for writing both React apps and Angular apps. And there are a bunch of tutorials for doing it, okay? If you're interested, email me, you know, and I'll send you back some good links, you know? In terms of incrementally porting things, I'm not entirely sure. I'd have to think about it, okay? But email me the question, and I'll ask the folks in the office, and I'll get back to you with some suggestions, okay? So in fact, I'll just put my email in there right now, just so that you can use that. So yeah, definitely email me that one, and I'll get back to you with an answer. Yeah. So finally, running short of time, so just to take 5 minutes, just to mention what you can do with Kotlin JS, okay? So as you know, at the moment, every modern language has to transpile to JavaScript to be cool, okay? So if you're doing Scala, or if you're doing Kotlin, or if you're doing F#, or if you're doing Clojure, you know, they have to have a version that transpiles to JavaScript, okay? Or they're not cool, okay? So Kotlin is no different, okay? So here's an interesting example. What I've got here is I've got a DSL, okay? So if I open up the code, Kotlin is well known for letting you create DSLs, okay? It's one of those things it's particularly good at, okay? So you see here, I've got a little Kotlin program, and inside here, I've got a DSL for defining training courses, okay? And this is a DSL that I've written myself from scratch, okay? So assembling a DSL in Kotlin is kind of what I like to call a lightsaber task, you know? It proves that you have well understood the fundamentals of the language. You know, you might not be the best developer in the world, you know, but you've definitely got familiar with the basics of Kotlin, and you know how to use the different constructs in the language and so on. Okay, so let's say we've assembled a DSL in Kotlin. Yeah, well then I can write the code, and then I can transpile it using Kotlin JS. Okay, so I've got a little web page here, and then I've got a little bit of Kotlin JS. So as you can see, what we're doing here is we're going out, And we're finding the bit of the document with an ID of DSL header, and we're registering an event listener. So when somebody clicks on that, then we'll build the DSL and we'll display it inside the browser. Okay. So just to show you that you can take the entire Kotlin language, and then you can combine it with code running in the browser, and it works really well. Okay. So, for people who know JavaScript or TypeScript really well, this isn't particularly appealing. Okay. But for people who don't know any TypeScript or JavaScript, but they've done a lot of server-side work in Kotlin or whatever, this is very appealing, and you can go in and you can create a React app entirely in Kotlin, if you're interested. Yeah. And in fact, we're doing a talk on that. Okay. So if you want to know about creating React UIs in Kotlin, yeah, then we're going to be doing a talk on that next week. Okay. But the really interesting thing that makes Kotlin different from, your Scala and your Clojure and so on, is they're really pushing multi-platform libraries. Okay, so this is where you create a Kotlin project, and there's a special area for common code. Okay, so this common code would typically be your data types. Okay, so let's say you've gone out and you've modeled the problem domain, and you have a customer type and an order type and an invoice type and whatever it happens to be. And the last thing you want to have to do is recreate those data types, in Java, in Kotlin, in Swift, in TypeScript, for your different clients and so on. Okay. Well, the idea is that you can define these once in Kotlin. Okay, so you can write these data types once in Kotlin, and then they can compile for the JVM, they can compile to JavaScript. If you're doing Kotlin native, they can compile to run on iOS and be accessed through Swift and so on. Okay. So there are a couple of use cases for this, So the first use case is you're a company and your company needs to produce a native Android app and iOS app, okay? But you only want to define the data types once, okay? So you can do that with a Kotlin multi-platform mobile library, and that will work very well. But also, the scenario that will interest you folks more is where, you've got your domain modeled, and then you're going to have the same data types on the server side in your microservices, whatever they happen to be, but also inside your JavaScript code in Angular or React or whatever. Okay. Well, by creating a Kotlin multi-platform library, you can define your domain once, yeah, and then you can use those types on both sides. Okay. And crucially, for the code in the browser, you don't have to use Kotlin JS if you don't want to. Okay, so you could use TypeScript or you could use JavaScript just as normal, but then you could use the data types defined in this Kotlin JS code. Okay, so basically you save yourself the effort of having to define all your data types twice, and keep everything in sync and worrying about the marshalling over the wire to and from JSON and so on. Okay. So this is something that JetBrains are pushing very, very hard at the moment. This is what they see as the killer feature of Kotlin going forwards. This is the thing it has that other languages don't. And this is another way to use Kotlin to really cut down the size of your code base. Okay, so this is another really good way to use types to your advantage. Okay, will it catch on? Will it prove worthwhile? Will the industry do it, or will it just be, yet another good idea that withered on the vine because it was never, adopted widely enough? Who knows? Okay, but it's something that at Instil, we're working with and playing with at the moment, and we have clients who've used it very successfully. In fact, if you go and look on JetBrains' site, they have numerous case studies, of big companies who've used this to their advantage to create, multiple clients, web clients, Android, Swift clients, and so on, all using the same set of data types defined once, so it's an area worth keeping your eye on. Yeah. So strong static typing has come a very long way from Java and C#. It's definitely not what it used to be. Okay, so static typing isn't what you might think it is. Okay, so static typing can now be discrete. It doesn't get in your way. It can mostly be inferred. It's now structural if you're doing TypeScript, rather than based on names, it's based on the structure of the things themselves. You know, we can do type mappings. You know, we can generate types based on other types. And if you're using things like Kotlin JS and so on, you now have this cross-platform element, you know, that you never had before. Okay, so that there's an awful lot going on in the world of data typing, and there's an awful lot that you can take advantage of. Okay, so it's not like it was in the Java days. Okay, you know, it's not going to get in your way and force you to define everything twice and so on. You know, it's come a long, long way further. Okay, and languages like Reason ML and so on, they push it one stage further still. You know, they go even further than that. You know, and I'm trying to heavily get into those languages at the moment in my copious free time. You know, but if I ever manage to get that far, you know, then if you invite me, you know, I'll come back and talk about how they take all of these one stage further, you know, but there's no way I'm competent to talk about that at the minute. Cool. So that's my thing. Yeah. So any questions? I see there's there. Yeah, interesting question there. Would you define the data types in Kotlin, or would you create more of an app in Kotlin? You could do both, okay? So let's say I wanted to create a React UI, you know, I could write the whole thing in Kotlin JS, okay? Or, yeah, I could just define the data types in Kotlin so I could use them on the server and the client, you know, and then I could write my React UI in JavaScript or TypeScript, you know? So it all comes down to what you're familiar with, you know? I mean, the thing that would concern me at the moment is just that Kotlin JS is very new. Okay, so if you go Googling to React questions, you know, with Kotlin JS as your language, you're not going to get an awful lot of solutions. Okay, so I would want to be very confident, you know, in my knowledge of React before I went out and wrote a React app in Kotlin JS. You know, so at the moment, yeah, I would go down the route of defining the data types in Kotlin, yeah, and then writing the app, you know, Angular or React or whatever in TypeScript, you know, rather than Kotlin, you know, and that might change, you know, as Kotlin JS becomes better known. It might not, you know, but that would be my preference at the moment anyway. Cool.
Thank you. We had another question sent through as well. So
yeah,
does TypeScript keep up with the ECMA spec? So like add an optional chain and the things that Babel are adding to the language, does TypeScript keep on check with that? Or
absolutely.
Are they going to diverge at some point?
No. As I understand it, you know, that they want to keep everything very tightly in lockstep, you know. So TypeScript always wants to be an extension of JavaScript, you know. That they don't want that horrible thing that happened with C and C++, you know, where in the beginning every valid C program was a valid C++ program, but then the standards started to diverge and everybody got confused and so on. So again, I'm not a TypeScript language expert, but as I understand it, they really want to keep the two in sync.
And then the last one we have here is, how well does TypeScript play with third-party libraries? So we were talking about those utility libraries earlier, and you know, you think about libraries like Moment and stuff. Do you have to write the types yourself, or do they provide the types?
You can get basically what you can do, and Ramda is a good example. So actually, if I just fire up my browser and I go to Ramda.js, and we scroll down here to the bottom, see what people do is they can write typing files. Okay, so let's say you have a JavaScript library and you want to use it from TypeScript. Well, first of all, you can just do that, you know, but let's say you want to do it with strong typing. Okay, well then somebody can go out and write a type definition file. Okay, and this provides strongly typed definitions for all the data types in the language. You know, so you can go out and you can get an external document, you know, and this gives you type definitions for all the data types in Ramda. Okay, and there's a separate area in the TypeScript website where they describe just how to do this. Okay, now Ramda is a special case, yeah, because Ramda is very difficult to strongly type. Okay, because again, as was said in the first talk, it is, you know, everything gets curried and there are all these really interesting functions and there's, you know, really heavy use of higher order functions and all this kind of stuff, but even there, you can get TypeScript bindings for random. Okay, so if you want to use a JavaScript library in a non-strongly typed way, you just can. If you want to use it in a strongly typed way, well, if it's a popular library, there will be like TypeScript bindings for it already defined. Okay, and those should work very well. But the more TypeScript, the more JavaScript weirdness that's being done, the harder it might be to define the static types. So there might be a few bumps in the road, but by and large, it should work very well.
That's awesome. Thank you very much. Very, very good talk. My mind was blown by the end of it, as per expected. So thank you everyone for joining the return of BelfastJS. Just want to say a huge thanks to our speakers, Stephen Ringland and Garth Gilmour.
Yep. Again, I just want to repeat the thanks. Like obviously it's a wee bit nerve-wracking bringing this back after so long, but like, no, I think it went really, really well. So thankful to have amazing speakers, like Chris said, and yeah, like let's bring on the next one. Yeah. All of our handles are there if you want to reach out or anything. I've been tweeting along the way as well. So, and this is also going to be recorded and put up on YouTube as well. So, yeah, it's been great.
Yeah, so we're in the process of planning the next event. It'll be in maybe 2 months' time. So we'll be sending out calls for speakers and interaction with the community, and there'll be a little feedback form going your way to help build this and make this as best it can be. But thank you again for everyone who joined. Give yourselves a virtual clap.